or my timeshare dog, as I like to say. So she's really my parents' dog, but we get to keep her sometimes. This is funny. I use this for my PyData. So here, maybe it's less of a sin to be an R user than it was a PyData. That was what the screaming face emoji was. But I know both Python and R, but I started using R in undergraduate. I was in the social sciences. I majored in decision science, but did a lot of stats courses. I was formerly at Etsy, where I worked there as a data analyst with the search team. And about 6 months ago, I joined Data Camp as a data scientist. If you don't know Data Camp, it's a data science online interactive learning education company. So we have over 180 courses now, R, Python, spreadsheet, shell, short videos, and then interactive content. Just to make sure we're on the same page, I wanted to go over briefly what A/B testing is. And you might have heard of it from another name, online experimentation, or similarly offline, randomized controlled trials. Now if we have this user here, Joe, and Joe comes to Data Camp for the first time. They're interested in learning deep learning in Python. And so maybe they find this page. This is our course page for deep learning in Python. Looks pretty good. But actually, if we're running an A/B test on the course pages at this time, there was an equal probability that Joe could have seen this instead. So there were a couple of different changes here, but the main one you can see is that we added the registration form directly on the page. And the idea here was we wanted to see, probably you won't be very surprised by the answer, but whether or not adding this form could increase registrations without harming anything else. So an A/B test, by randomly assigning people to one of two experiences, allows you to know that any difference between what those people do on your website is probably because of the change that you made. So this is different than, for example, looking at a time series graph of our registration rate and trying to tell, okay, we launched our product on October 10th, and you're looking at this wavy graph, and you're like, okay, it's sort of like bumped up. Was that our change, or was that another product change that happened at the same time, or was that this big tsunami that happened somewhere? And just there's so many different factors, versus A/B testing allows you to control for all those variables because you're randomly assigning people and it's happening at the same time. A/B testing is really widely used. So all the big tech companies use it. Amazon, Facebook, LinkedIn are all running tens of thousands of experiments each year. And even for smaller mid-sized companies. So at Data Camp, I was brought in to help build their experimentation system in-house. But for a lot of companies that aren't tech companies, maybe that doesn't make sense. So they might use a service like Optimize or Qubit, where they pay and then they get an experimentation platform that will integrate with their data. And then all the data engineering for that, the statistics, the visualization is kind of taken care of for them. And my perspective coming in, as a social scientist, I would do in-person experiments, psychology experiments, where maybe we were lucky if we had a couple hundred people because we had to pay for them. I come to Etsy, where there are millions of visitors daily to the search pages. There's a data engineering pipeline already set up. So when I was at Etsy, I'd come in, get my cup of tea, I'd sit down, and I would get to see what we called Catapult, which is our internal A/B testing tool. And it had a list of all the experiments that were running and all that have ever run since 2013. If I clicked on one, it would show me a description of the experiment put in by the PM. Then it would have all the metrics already calculated, so I would see how many people are in it, what's their search click rate, what's their conversion rate, etc. And it would even do the stats test for me. So I thought, this is a piece of cake. Why do they need a data analyst to be working on this? Because generating numbers is easy. Generating numbers you should trust is hard. This was said by the Microsoft experimentation team in their paper, which I'll also link to at the end. And that's where we come into these guidelines. So what I'm going to do today is talk you through some situations and problems that you might face as a person in data working on A/B testing, and how these guidelines can help you solve them. So first, I want to make clear that in these 10 situations we're going to talk about, this is not based on any particular person that I've worked with. All the PMs and engineers, they're all really great. And just to emphasize this, this is Bowen. Oh wait, nope, this is Bobo. Any resemblance he bears to a PM I worked with at Etsy, either in picture or name, is just pure coincidence. He is our fictional PM for the day. All right, so Bobo comes to me and he says, I've got a great test idea and it's going to increase registrations, search clicks, and course starts. All right, what's the problem here? Well, what happens if the test increases registrations by 5% but decreases course starts by 3%? What do? Do you launch it? Does it matter that the increase was bigger than the decrease? This is why I suggest having one key metric per experiment. It helps you clarify decision making. So you're going to know, okay, what is the main metric we care about, and that's going to help us decide whether or not to launch our experiment. Now, you can have additional what we call guardrail metrics that you don't want to negatively impact. So for example, at DataCamp, we might, in that example test I gave where we wanted to increase registrations, we're a subscription business. So we'll monitor subscriptions to make sure that those don't go down, because we wouldn't want that to happen even if registrations went up a little bit. So Bobo comes now, a little bit dejected, so I said, all right, I have 100 other test ideas. How long is each going to take to run, and which ones should we choose? Because I'm willing to admit that maybe 100 tests, a little too much, so let's cut it down to 50. Well, ideas are actually pretty cheap, even good ideas. If you've had PMs or people working and at the company for a while, maybe doing user experience research, they have some really good intuition. So how do you prioritize them? This is where you use your key metric to do a power calculation, and bigger is better with power. If you're not familiar with power, it's about avoiding false negatives. So saying that there isn't an effect when there is one. And generally you want to design an experiment to have 80% power, and that means you have to do this around expected change. So you can't just say, oh, I want 80% power, period. It would be 80% power to detect a 10% increase or a 15% increase. And that means you'll have 80% chance you'll detect that if there is one. So for example, if we had a page like this where we know we have 10,000 people each day, 10% conversion rate, I can answer the question, how many days does it take to detect a 5% increase? And sometimes when you do this power calculation, what you find is that it's going to take 2 years, 12 days, and 5 weeks. So what that means basically is that you should probably not run that test. You do not want to be waiting around, and your VP certainly does not want to be waiting around for 2 years for the results. So generally what you want to do there is either say, okay, I was thinking maybe have a 5% impact. Is it reasonable that would have a 10% impact, which we could actually detect? Or you could say, well, I have this other test that I could detect that change in only 2 weeks, so I should probably run that instead, because power is related to how many people you have in your experiment. And so if you're trying to work on a page that doesn't get a lot of people coming to it, you're not going to have great power to detect an effect. If you want to do that, I definitely recommend Booking.com's power calculator. So they built it out so you can enter a number of daily visitors, conversion rates. It will tell you for a different amount of days what effect size it can detect. Booking.com has been running experiments for a while now. They have over 120 data scientists in the organization. And a whole dedicated experimentation team, and I do some really good tooling. So now Bobo, we've launched an experiment, and he comes and he says, oh, I checked the experiment today, we've significantly increased conversion rate, stop the test, stop the test, stop the test. So do you stop the test? Well, you might be peeking. So this is a post, this graph from a post by Dave Robinson, and what it's around is that if you ran thousands of simulations of null experiments. So basically, you randomly assign people A and B, but there's no difference. They have equal likelihood of conversion. And you do this over 20 days. What percentage of the time, what percentage of these simulations, if you stopped it, if it went below P equals 0.05 at any point, how many of those would that happen to? And on any given day, it should only be around 5%, your expected false positive rate. What this graph is showing is if you stop them early, so all these little red lines, that's more than 20% of the time. So you will hugely inflate your false positive rate if you do that. And that's why I recommend running the experiment for the length you planned on. Don't be that corgi getting off track. He wants to run the whole track. So stick to what you arrive to with your power analysis. Now, you can do other techniques, such as things called always valid inference or sequential testing. So always valid inference is something Optimizely does for their platform. The idea is they've built it such that no matter how many times you check your experiment, your p-value will only be below 0.05 5% of the time. So you're not getting that inflated false positive rate. And sequential testing was designed for clinical trials. The idea being here is maybe they've done their power analysis, they're going to do 1,000 people for drug A, the old drug, and drug B, the new drug. Well, you run it over time, and if the first 20 people getting drug B, if they all get really, really sick, you don't want to keep running that test and hurt 980 more people. So this is a method that basically allows you to stop early if things are a lot worse, or maybe ideally a lot better than you thought they would be. So now we have another test of OS. All right, fine, that test, you made me not stop it early, so I know it didn't work overall, but when I look at Canadian users on mobile, we increased conversion by 10%. And then he makes up some story. Oh, I guess, those Canadians, well, we were highlighting maple syrup, so that's why. Well, the problem is this is multiple hypothesis testing, and it will increase your false positive rate. So the idea here being is, well, if you do one test, so say like no peaking, you only have that 5% false positive rate, you're a promise. If you do tests on either multiple metrics or lots of segments, you'll get, it's very likely that at least one of them will pop up significant, even if there's no difference. You should try not to look for differences in every possible segment for this reason. You can pre-specify hypotheses, so say at DataCamp, if we run a promotion, it's very likely that it will work differently in developing markets than developed markets, because what $200 there would buy is very different. So I could pre-specify that ahead of time, and then I know, okay, I'll be checking those segments. Or you can even run separate tests. So maybe you make a change to our core search page, but we know that it's going to look pretty different on mobile than desktop, so let's just run it as totally separate tests rather than doing it post hoc. And you can use methods to adjust for multiple hypothesis testing. So if you have a stats background, you might have heard of Bonferroni correction. The simplest ones of these do something just like adjusting your p-value threshold to be lower based on the number of tests that you're doing. So for example, if you're running 5 hypothesis tests, well, instead of having to meet the threshold of 0.05, you have to meet 0.05 divided by 5. But the problem, of course, is that then that makes it harder for your main test, so maybe your overall test or the segment you care about the most, to show you that it's significantly better in the treatment versus control. So you made your test more conservative. So now Bobo comes, yet another experiment, say, oh, it was a big success. I know the split was 50.5 versus 49.5 instead of 50-50, but that doesn't seem like very much, right? Like, can't we just launch this? Well, actually, you can have a very, very low probability of this happening if your randomization is actually working. And this problem is called bucketing skew or sample ratio mismatch. You need to make sure that your experiment is balanced, and your analysis is going to end up like this guy. And you can use a proportion check to test this. And if it's unbalanced, you do not use the result. And the reason, again, is that if it's very unlikely it randomly happened, well, then it wasn't random. And what's also unlikely is that the people you're dropping from one group, that's random. So, for example, Microsoft wrote about this, that they made a change such that people on Internet Explorer in the treatment group weren't getting put in the experiment properly. Now, Internet Explorer also clicked less on the ads. So if you no longer have those people in your treatment group, then it's going to look artificially better because all those people not clicking are still in the control, but they're not in the treatment. So unfortunately, it is difficult to debug, but a really good method is to check these segments and see, okay, were we systematically dropping people on certain browsers, in certain countries, on mobile, etc. Now, Bobo, being very industrious, is becoming an armchair analyst and says, I've read about how multi-arm bandits is much better than traditional A/B testing. Why don't we do this instead? And the problem is that often, well, he probably doesn't have it, but even the analysts and the scientists, and and other consumers may not have a full understanding of the assumptions of those methods. So if we take multi-armed bandits, for example, I won't go into it too much, but it rests on something called the stationary assumption, which would essentially mean that if you're on a website that at any point during the week and during the day that a person enters, they have an equal probability of converting. And that's very unlikely to be true. So for example, your conversion rate at 2 p.m. on a Wednesday is probably very different than Saturday at 3 a.m. And that violates the assumptions of this method. That's why I would recommend not overcomplicating your methods. Get the basics right first. And I hope by the end of this talk, I'll have convinced you that it's not actually super easy to do this. Because designing tests right is usually going to give you better returns than using super sophisticated methods. So I would definitely recommend putting in more of that effort in front in explaining to product managers, other people you work with, how these methods work, why you shouldn't peak, etc. Designing robust statistical tests rather than maybe worrying about the coolest new trend you've heard about. So we're on another test, and Bobo says, well, okay, I know nothing went up as we had hoped, but nothing went down either, so why don't we just launch it? And the problem is it may be a negative effect that's too small to detect, and it also might add technical upkeep. So for that first point, if you've done your power analysis, maybe you said, okay, we powered it so that we could detect a 5% increase in conversions. And you ran the test like you were planned on, and you didn't see an effect. So maybe there was a 2% increase, right, that you just weren't powered to detect. Well, there might also have been a 2% decrease. So that's what you should be worried about. Generally, be careful of launching a neutral. You want to decide whether to do so beforehand. And there are sometimes cases where it's appropriate. So for example, there may be a test that you didn't actually really expect to increase anything, but it lays the foundation for future tests. And you can use a technique called this is called equivalence testing or non-inferiority testing. So what this technique is that it means basically I just want to make sure I don't make things any worse by at least X%. So I'm not necessarily expecting anything's going to go better, but let me try to just avoid any harm here. Now Bobo says, well, we just finished this experiment that you've never heard of and we've never involved you in on a totally different part of the site, but you can analyze it for us, right? Now, here we come to one of my favorite statistics quote, which is from Robert Fisher. To consult the statistician after an experiment is finished is often merely to ask them to conduct a post-mortem examination. They can perhaps say what the experiment has died of. Now why is a little bit more, but the idea here is that you should have a data scientist or analyst involved in the whole experimentation process. And they can help with a couple things. One, should it be an experiment at all? So there's a nice post I'll link to at the end of this presentation called Please Don't A/B Test That. And it basically lays out some questions you should ask before deciding whether to do an A/B test. Because often companies and product teams, once they have A/B testing as a possibility, they'll just think, oh, we gotta A/B test everything. I don't wanna launch any features without an A/B test ever again. Because why wouldn't you wanna measure everything, and what if this thing harmed that? And the problem is, one, it's not free, quote unquote, free to run A/B tests, even if you're not paying for a service. There's the analyst time, the PM time, the engineer time. But also, again, you might run that power calculation and say, okay, you're changing thing on such a small part of the site, unless you expect this metric to double, we're never going to detect a change within a reasonable time period. An analyst or data scientist can also make sure you can measure what you want to measure. So you might have the experience where they come to you and they say, oh, this was our success metric. But the problem is, actually, we don't record that data. We can't, if it was, say, a path of behavior, maybe there's no way to tell who took this path of behavior. And then you're not able to help them out, and maybe the whole experiment has to be rerun. Finally, they can surface problems along the way. So, for example, if that experiment had bucketing skew, but no one pointed out, well, maybe they've run it for 3 weeks, then now you say the data is unusable, when perhaps if you've been involved the whole time, then you could have seen that on day 3 or day 4 and brought it to their attention and fixed it. So now Bobo says, well, we accidentally added everyone on the website to our little small search experiment. can we still use our dashboards to monitor it? So, will it kind of like trickle down or trickle up so that the overall results of everyone on the website, we can still see our change in our little like tiny segment. Actually, non-impacted people will add noise, and this decreases power and the ability for you to detect an effect. So the idea here being is if you have people in A and B who didn't see anything different, so actually they don't differ between A and B, they're just adding noise. You want to only include people in your analysis who could have been affected. And this also means starting to track the user after they see the change. So for example, if I'm running a search experiment, so I was at Etsy and someone comes to our homepage, they buy something and then they do a search, we don't want to count that person as a conversion in our search experiment because they couldn't possibly have bought because of a difference that they saw on our search page. But also can be a little trickier. So for example, what if we change the threshold for a free shipping offer from $25 to $35, and this was on the cart page? We could put everyone who sees a cart page in our experiment, but would someone who has a cart of $50 see anything different in the control versus treatment? No, they'll see free shipping all the time. What about someone with $10? Same thing, they'll not see the free shipping either in the control or the treatment. So actually in this case, you want to narrow it down just to those people on the cart page between 25 and 35 because they'll have a different experience. And in our final situation, BOA comes and says we spent 6 months redesigning this page. We made all these changes to it, but the A/B test said it did worse. Why? Why, dear Lord, why? Well, time was wasted, and with this many changes, it's often hard or even impossible to tell what was the problem. Was it changed? Was it the second change? Was it the interaction of change 10 and 15? Sometimes you can tease it out a little bit if it changed different parts of the page or different calls to action, but it's just going to be really hard to get anything from this. So what you want to do is focus on smaller incremental tests. You can work in these design, develop, measure cycles. So there's a really nice example of this from Dan McKinley, who was formerly a principal engineer at Etsy, where he said they did a test on infinite scroll on Etsy search results. So basically, now if you kept scrolling, like things would just keep popping up, basically forever. Like if you search jewelry on Etsy now, it has over 1 million results. So there, they spent all these months developing this feature, they launched the A/B test, and it didn't work. And so actually they went back and they tested the assumptions that they had. So they said, okay, why did we think this would work? Well, we thought more results would be better. So instead of doing infinite scroll, let's go back and let's just change it from 40 results displayed on a page to 60. Does that help? Turned out, not really. Another assumption, speed is better, right? It's slower to have to click that page next and have the whole page reload than just like when you scroll a little bit, the results show up. All right, they artificially, I can't remember whether they either increased page speed or what's actually a lot easier is artificially decreasing your page speed. But in either case, it didn't really work. And so if they'd done this at the beginning, it could have saved them a lot of times. And for example, if this was a test where really it was one thing, it was just a big feature. But for example, if it was a course page you're redesigning and you have 10 things you want to do with it, maybe break them up. And it's okay if one thing works and the other thing doesn't. I want to conclude just with a quick recap of all the guidelines in case you're someone who likes to take photos. The slides are available online. I'll share that link at the end. But these are the 10 guidelines I recommend. I also have a blog post on this, which includes 2 more guidelines called 12 Guidelines for A/B Testing. So feel free to check that out. Yeah, I thought 12 was a little much for a presentation. It sounds a lot too. But so these are some of the research papers. One of these is the one from Microsoft I mentioned, but the first one is a decade old now, but is a really good starting point, especially if you've never done experiments kind of in any form. The next year from Microsoft, their team, experimentation team, does some of the best work out there. They publish a lot of research papers. And then finally, a little bit less technical is a paper from Booking.com about how did they bring experimentation to everyone at Booking and really scale it. And then also, I'm a big fan of presentation and blog posts. So Dan McKinley presentation on the top goes through that infinite scroll example. Jonathan Parks did a nice blog posts on how they scaled Airbnb's platform as the company grew. Tyler Reeve had that post, please don't A/B test that. And then finally, my former colleagues at Etsy recently wrote a post about how Etsy has started to handle peaking in A/B testing. So the idea here being that they're doing some of that methodology I mentioned that is a little more advanced, because basically the idea there is sometimes you do want to peak if you had maybe there was a bug and suddenly people are having a horrible experience, you want to stop the test, or maybe you knocked it out of the park, and it's just because it had a bigger impact than you thought, and you want to keep velocity going. And so with that, I forgot the link to my presentation, but I'll find it in a minute. That's my blog, Hooked on Data, where you can also find, I have a speaking tab that has links to all my previous talks as well. I'm on Twitter at RobinsonES, and with that, thank you, and I'm happy to take questions now.
One thing you mentioned was that when we calculate the power, we also have to estimate the effect size. So my company doesn't always have that habit when launching tests. It's usually directional. How would you suggest going around getting that estimate to be good?
Yeah, so actually it was a lot easier at Etsy in some ways. So it depends on the size of your company. Way back when at Etsy, we were big enough that, and we were generally going for metrics that were really coarse, like adding to cart and buying. So it was very unlikely we were going to have a 10 or 15% impact on that. So actually what we did was basically always assume we had a 1% impact, and how long would that would take. And that's actually what we used to do the power calculation for our tests. But now I'm at DataCamp, and it's a very different situation. So the first thing is we couldn't detect a 1% increase, basically to any of our metrics. We just don't have that traffic. And so, it's a little more difficult. And actually, instead, honestly, right now, it's a little, we're still doing it, but it's a little more ad hoc. It's first we start out, okay, the longest we really want to run an experiment ever is pretty much a month. So let's start from there. Okay, a power calculation, say, going backwards. In a month, we could detect an effect size of, say, 15%. All right, first pass, is that way bigger than we think is going to be possible? If so, let's go back to the drawing board. Okay, does that seem somewhat reasonable? Yes. All right, well, if we scale it back to kind of 3 weeks or 2 weeks, what does that look like? So actually now we really don't do things where it's like, oh, it's going to take 9 days. We generally think of, okay, 1 week, 2 week, 4 weeks, what does the effect size we can detect look like? And then sort of, honestly, as a group, just kind of decide, okay, what seems reasonable? How big an intervention? Like the registration form on the course page, we knew that was probably going to have a pretty big effect versus some more subtle tests. So I know it's not a perfect answer, but I've been learning a lot about what it's like to run an experimentation at a smaller company, and it's pretty different. So,
Thanks for sharing. So I have a question about, I think during the talk you mentioned that there are some features good for A/B testing, and there are features not really good for A/B testing. And what's the question you were asking for doing A/B testing?
Do you mean okay, product features. Yes, so Televi's post, the first is it, the first 2 questions before you want to run an A/B test. Is it, do we need to measure kind of precisely what effect this has? So basically, do we want to be able to put a number, okay, this product launch increased, registration or whatever by 5, 6, 7%? Or is it, sort of okay not to know that? And then with that, is there any possibility that this could have a negative effect? Now, all right, basically anything you would come up with some theory of why it would have a negative effect, but reasonably, is it likely? And so essentially, you have to say yes to one of those 2 questions, or you shouldn't run it. So some features that are not that good are, for example, just bugs are things you really shouldn't A/B test. So if you have a design bug, or some users can't see something, that should just be fixed. If you want to do some, again, pretty foundational stuff, or things backed by user research, perhaps. So okay, we just think this is going to be better for our users. They've told us this is the feature they've been requesting for a while. You might not A/B test that. And then the final one is in the guideline I gave is if there is a really, really big fundamental change to your website that you want to do, or a page, if you can, trying to break that up into smaller pages. So for example, I've been working with my team at DataCamp on redesigning the desktop page. And they came up with a really cool final design that had a lot of things different. Like it pushed things down, it added reviews, like it was just a bunch, and I think they're all great. But I said, look, if we run this and it doesn't do well, I can't tell you why. So let's break it down. You don't always have to do one feature. So maybe there are 2 things on the page that both are about social proof. So showing people, oh, people take this course and they like it. So maybe we do those together. We can group that. So that's the way I think about it in terms of which features and how do you want to test them.
Interesting.
Yeah, and definitely check out the Tyler. We've also had a couple more questions you should ask, and I think I really agree with all those points. Yeah.
I'm sorry, I was just wondering because for DataCamp, do you guys measure like people's engagement on the website as well? Engagement meaning like how many minutes do they spend like coming back every week to DataCamp? And I'm assuming if you are measuring that, then the variables that you have will be kind of interconnected with each other. For example, like you have leaderboards for like some of the lessons, and how do you separate like leaderboards and like let's say like course time, like shorter course time, maybe like bring people, like how do you differentiate that?
Yeah.
Like how do you separate it? Like because it's kind of like it works together.
Right. So there are definitely some correlated metrics. So for example, so DataCamp, if you do an exercise, you unless you ask for the solution, you get like XP points, right? So like that's probably the amount of points someone gets is usually pretty correlated with the number of exercises they do. If you don't do any, you can't get any XP. So yeah, so generally in terms of what we look for, definitely depends on the test. Engagement is certainly one of them. So for example, we ran a test where we promoted a project for a week and offered triple XP, and there we were seeing, okay, could we get more people to take this project, and maybe this would be another method to promote projects and get people trying different types of DataCamp products. We also run some tests on the course search page, which is looking like, okay, if we offer recommendations, will more people click on a result and start taking a course? So that being said, time on the platform is kind of interesting. I looked at some things like the time between doing certain things. So for example, can we like shorten the time from landing on a course search page to like starting a course, right? So it's sort of probably a better experience if someone doesn't spend like 20 minutes trying to wander around. That being said, one thing I talked about in a previous talk is proportion metrics are really nice because they're well behaved. Metrics like time or revenue are super skewed distributions. So at least time, you're getting people in your experiment because they're spending time on your website, but something like revenue, probably most of your customers aren't buying anything. And at a place like Etsy, most people maybe buy like $40, $50, $60, $70. Then someone buys a $50,000 diamond engagement ring, and like there goes your revenue metric. So actually I would say like you certainly can do some things, but I'm always a little more cautious being like with those metrics that just traditional statistics tests aren't going to work very well.
Who was asked the last questions?
Take your chance.
Final chance.
So I have 2 questions. First one,
Only one.
sorry.
You can ask me afterward if you want.
So first one is, did you check the assumptions before or after the test, like normal distributions or something?
Yeah.
Yeah.
So,
And okay, the second one is, are you still use the p-value equals to 0.05, or you use another numbers for that?
yeah, so we actually use p-value equals 0.1, which we use at Etsy, is also used at Booking. Basically the idea there, right, is you're probably gonna get more false positives then, but often, most of the time we're more concerned about missing a change that's good than launching something that maybe actually didn't really have the impact we hoped it had. So that's the second one, but that is consistent across all our tests. So someone asked at my talk yesterday, do you change the power threshold, the p-value based on the test? The answer is no, and I don't think that's very common. With the checking the assumptions, that is, like I said, that's what's really nice about the proportion test is because it's where there aren't really, it's only kind of distributed one way, if that makes right. A proportion test is like you had this many people and this % of them did that thing. So that's why actually basically every other metric is not normally distributed. So for example, at Etsy, I'd give this in a talk before, we had to, another analyst worked on a bunch of simulations and analyses to figure out, okay, we developed a metric that's average converting browser value. So given someone buys something, how much do they pay? Trying to see if that differs between a control and treatment. And a t-test, which you can run it, performs terribly. So if there is a difference, it's not going to pick it up because it doesn't meet those assumptions. And actually, so he did some work on figuring out, okay, log t-test, Wilcox rank sum, all these different options, which ones perform the best. And basically, by that means is like which ones essentially are trying to find out have the highest powers, because all of them had about the same false positive rate. Yeah, so in this case, like at data kit, most of the proportion tests, there's not really any assumptions to check, but with other metrics, definitely. And often when they don't meet those, it's a pretty involved process to figure out the best one.
All right, then thank you.
Yeah, so I'll just do a quick survey. How many of you, this is the first time you come to our event at Taiwanese Data Professional? Wow, look around. So very lot. Great, so we're very glad that we have some new faces. We got wonderful speakers in the past and also in the future. So our we do have a. We want you to follow us on. We are on Twitter, on Facebook, and LinkedIn. This is our email. If you want to join our Slack workspace, send an email to us so that you can continue. The benefit of there is we share a lot of events, articles, and thoughts, and you can also ask questions like, who here have questions at work or a school project where you feel like, oh, I don't really want to ask my coworker. Anyone experience that? Oh, only one. Okay, great. So, great. You all have a wonderful environment. That's great. But if you still want to get connected with us and learn more about it, please join us. And we're also looking for more volunteer organizers because we can only put out this event with everyone's input. And we're taking a break for November and December simply because our volunteer community, we have vacation plans, so we can't plan more events for you all. But if you want to see more events happening for the next 2 months or so during the holiday season, please contact one of us. And then this way we'll have more human power and then be able to get the events going. So thank you all for coming. We have the events, we have the space for another about 7 minutes. We do need to rush out because we have the reservation at 8:30, but yeah, feel free to network within the next 5 minutes.
I'll be the speaker. I like the third speaker.
Oh,
Yeah.